మాట్లాడకండి అందరు మాట నిలబడుతున్నాడు గలీజ్గా. మీరు అట్లా వెళ్ళకండి, రండి.
ఇక్కడ ఎక్కడ వస్తుంది లైవ్ కనిపిస్తుంది చూడు, దీంట్లో ఎక్కడ వస్తుంది?
మీరైతే వాళ్ళతో మాట్లాడుతుండండి.
అరే ఇక్కడ మాట్లాడాలి, ఇక్కడ కనిపిస్తలేదు యూట్యూబ్ దీంట్లో. మై ఛానలా?
ఇప్పుడు లైవ్ అని వస్తుంది. అక్క వినిపించింది నా మాట.
Yeah. So the main purpose of this particular live session is just in order to clarify the doubts for especially the engineering first BTech students, but it doesn't mean that only engineering students can live, right? So come online. Right. So students, spectroscopy hi Sai Kumar, hi Nana, Pradeep, hi Pradeep. Yeah, start your questions. Hi Pradeep, is it audible? Is it audible? No? Vishal, hi. Pradeep, yes sir, okay. Redox titrations, okay. So first let for 5 minutes let them come. Harshini, hi. Redox titration. Pranati, hi. Hello. Kunal. Next Pranay Kittu, hi. Vaishnavi, hello. Vedaprakash, hello. Rapul, hi. Renuka, hi. So redox titration is nothing but the titration between the reduction system and oxidation system. And Vinay, hi. Haritra, hello. Pranay Kittu, ఇంకా తినలేదు నాన్న, తినాలి. సార్ స్పెక్ట్రోస్కోపీలో ఇంపార్టెంట్ క్వశ్చన్స్ చెప్పండి. సో ఇంపార్టెంట్ క్వశ్చన్స్ ఆల్రెడీ హ్యావ్ సెండ్ టు యూ. సో ఫ్రమ్ దట్ ఓన్లీ ప్రాబబ్లీ ద క్వశ్చన్స్ విల్ బి రైజ్డ్. So important questions, give the principle of the UV visible spectroscopy, write the applications of IR spectroscopy, right? Define chromophore and auxochrome with suitable examples, and importance of IR spectroscopy, all that, right? Bhupesh, hello. Pranay Kittu, 9 classes age చెప్తారా అంటే ఏంటన్నా 9 classes అంటే? I couldn't get you. Abhinay, Abhi, hi, hello. Someone, Vinay, explain injection molding. Okay, I will just 5 minutes. Lalita Madhuri, hello. Sachin, hello. Pradeep, sir, tell me about the biomimicry. So Chatan, I will just a moment. So biomimicry, first and foremost, the thing is Biomimicry is nothing but mimicking from the bio conditions. That is, mimicking from the bio condition means Pranay ki to a subject chemistry. Pranay, where are you from? The biomimicry is nothing but obtaining the clues from the environment in order to innovate the new things. That is nothing but the biomimicry, Nana. Pradeep. Obtaining the clues from the environment in order to innovate the things, that is in order to find out the new things, is nothing but biomimicry. So redox titrations means the titrations between the oxidation system and the redox system already that you have done in the experiment, that is estimation of ferrous ion using potassium permanganate. So the same experiment, if you write the same experiment, you will get the full marks. Next, Nitin Reddy, hi. Asai Vangala, hi. Abhinaya, Abhi. What is pitting corrosion, sir? So pitting corrosion is nothing but the corrosion which takes place due to the development of small pits or holes. Pits means small holes on the surface of the material. So whenever the pit is formed, then the non-heterogeneity is created. So once the heterogeneity is created on the surface of the metal, then the metal is more susceptible to undergo the corrosion process. So the pitting develops the heterogeneity, and you are well versed that for the wet corrosion to occur or takes place, definitely the heterogeneity is required. I hope you got it. Sai Tilak, next Sindhu Pranay Rao, hi, good evening. Sindhu Reddy, hi. Manish Ravan, hi. Sai Tilak, hi. Sai Kumar, water line mark. So I will explain, just a moment. Sai Tilak, sir, important questions please, sir. Important questions అంటే నిన్న ఇచ్చినయేనా ఇవి, ఎందుకంటే ఇంకా కన్సైజ్ చేసి నేను ఇవ్వలేను, బికాస్ the questions can be asked from those. So if you have any doubts, please ask me related to that. Veda Prakash, sir, mechanism of electrochemical corrosion. Okay, I will explain. Nitin B, hi. Prabha Vishal, hi. Abba Vishal. Sai Tilak, please sir, once more. Sai Tilak, ఏం చెప్పాలన్నా, what you are expecting from me, just tell me. Divya Kandukuri, hi. Sai Tilak, important questions. So important questions already have sent yesterday. I have sent yesterday to your corresponding WhatsApp group. Check them. Okay, sir, mechanism of electrochemical corrosion. Mechanism of electrochemical corrosion is nothing but hydrogen evolution corrosion and oxygen absorption corrosion. Hydrogen evolution corrosion means whenever the corroding medium is acidic in nature. Only important question enough, sir. So important question enough ante atlem ledu, but the thing is so most oftenly these questions can be asked in ardham ante. That doesn't mean that only these questions will be asked in the exam. So but first you study these important questions, and after studying and after gaining the full knowledge about these important questions, then you start reading the other one. That is the meaning of the important questions. It doesn't mean that you are not supposed to read the other questions, right? Indra, so injection molding, Sai Prakash, hi. Divya sir, about conducting polymers. Okay. Abhinaya B, electroplating and electroless plating. Electroplating is not there in your syllabus. Electroless plating is there, and the difference between electroplating and electroless plating is, electroplating is nothing but plating some substance on the surface of the metal, that is coating some substance on the surface of the metal, making use of electricity. That is nothing but electroplating. And without making use of electricity, if you are going to use the reducing agent for coating or plating the substance on the surface of the metals, then it is nothing but electroless plating. Veda Prakash, sir, tell about CFT, brief explanation. So CFT చెప్తాను ఒక నిమిషం. Shravani, hi. Samantha Vinay injection molding చెప్తానా. Next Sai Divya sir about conducting polymers definitely. Abhinay Abhi electroplating electropressing. Abhi already just now I gave the definition of electroplating and electroplateless plating. So I hope you got it. Veda Prakash sir tell about CFT briefly చెప్తాను. సాయి తిలక్ ప్లీజ్ సార్ వన్స్ మోర్ ఇంపార్టెంట్ క్వశ్చన్స్. ఇంకా మోర్ ఇంపార్టెంట్ క్వశ్చన్స్ ఏం లేవు నాన్న, ఇంకా అవే ఇంపార్టెంట్ క్వశ్చన్స్. సో ఇంపార్టెంట్ క్వశ్చన్స్ అని అంటే మళ్ళీ చదువుకుంటా పోవాలి. సో జస్ట్ ప్లీజ్ డూ వాచ్, దట్ ఈస్ see in the WhatsApp group. Lalita Mother about plastics. Okay, hi sir, I am Shravani. Nikita Talluri sir, what is ion selective electrode? Okay, right. So Lalita Madhuri about the plastics are nothing but, and this is very important question from the examination point of view, that is the plastic and the difference between the thermoplastic and thermosetting plastic. And coming to the plastic definition, plastics are the high molecular weight organic polymers which can be molded into any desired shape with the application of heat and pressure in the presence of catalyst. That is the definition of the plastic. And coming to the classification of the plastic, there are two types of plastic. The one is thermosetting plastic and thermoplastic and thermosetting plastic. So thermoplastic means which is not resistant to heat, and thermosetting plastic is resistant to heat. So since thermoplastic is resistant to heat, thermoplastic is not resistant to heat, it can be easily mended upon heating, whereas thermosetting plastics cannot be easily mended upon heating, right? And as thermoplastics can be easily mended upon heating, we can say that these are weak, and thermosetting plastic cannot be easily mended upon heating, so we can say that these are strong. And since these are weak, definitely we have to discuss what are the weak forces present in the thermoplastic. The weak forces present in the thermoplastics are the van der Waals forces, and the strong forces present in the condensates, that is thermosetting plastics, or the covalent bonds. So that is the case of the plastics. I hope you got this, Lalita. Hi Shravani, hi. Nikita sir, what is ion selective electrode? Ion selective electrode means the electrode which is specific or selective only to one particular ion. For example, let us say that in one particular solution there are n number of ions, like sodium ions are there, chloride ions are there, potassium ions are there, and so sulfate ions are there, carbonate ions are there, so many ions are there, right? So many ions are there, and from those ions, for let us say that this particular ion selective electrode is specific only to the H plus ions. Now it picks only the H plus ions which are along with the other ions in the solution, and during the picking of the H plus ions from the solution which are along with the other ions in the solution, due to the movement of this H plus ion, some potential is developed. So that potential which is developed is nothing but the EMF. So this is about right. So ion selective electrode, Sai Kumar. Electronic transition. So electronic transition at transition of electron from bonding molecular orbital to anti-bonding molecular orbital, or the transition of electron from ground state to excited state is nothing but electronic transition. Sai Divya sir, conducting polymers. So conducting polymers, the polymers which do conduct the electricity are called as conducting polymers, and the main reason for the conduction of the conducting polymer is due to the presence of the conjugation. For example, if you see the I hope you got the material, right? Just see the structure of the polyacetylene. If you see the structure of the polyacetylene, you will find the n number of bonds which are arranged alternatively, and those bonds which are arranged alternatively are the pi bonds. And already we know that the pi bonds are the weak bonds, and whatever the electrons which are associated with the pi bond are flexible in nature. So since they are flexible in nature, they will move from one place to another place, and these movement, what are moving, the movement of electrons is taking place. So as the movement of electrons is taking place, and we know that electrons are the charge carriers, right? So since electrons are the charge carriers, whenever this conducting polymer is placed in the electrical field, they will carry the charge along with them, making the conducting polymers to conduct the electricity. So when we have only the two, the one is polyacetylene and the polyaniline. The same mechanism is involved in both of the conducting polymers. Right. So such important questions in spectroscopy. So spectroscopy, I don't know why you are asking, emphasizing the spectroscopy. Only it is very short unit, Nana. Important question is the itself. The whole unit is important, because the thing is, it is very short unit. What are there? The principle is there, right? Principle, instrumentation, right? Principle, instrumentation, and applications. These are important. In the case of UV visible spectroscopy, electronic transitions, what are the terms involved? Oxochrome, bathochrome, that is oxochrome, that is chromophore, bathochromic shift, hypsochromic shift, hyperchromic shift, hypochromic shift. So at the total, any pages on only 14 pages are there, 14 to 15 pages are there. Just read out everything, because we cannot say what is the question which is going to be appeared, because 15 questions, it doesn't may take much time, and I have clearly explained each and every topic for you. So that. Okay, Nikita, sir, in nanotechnology, which application is important? So nanotechnology, only 3 applications are there, Amma. That is application of the nanomaterials in medicine, in catalysis, environment, and apart from that, biomimicry is there, right? So for example, medicine. So this particular nanomaterials can be used in the cancer treatment. So because the nanomaterials are highly selective, so since the nanomaterials are highly selective, they go and reach the desired active site and kills the cancerous cells. That already I explained in the class as well. So that is about the medicine. And in the catalysis, already I have discussed that as these nanomaterials have large surface to volume ratio. So since a large surface to volume ratio is present, so definitely that is a feasible surface for the catalysis process. So since it is feasible condition for the catalysis process, these nanomaterials can be used easily for the catalysis process. And coming to the environment, these can be used in the photovoltaic cells, in the fuel cells. And biomimicry is nothing but, just now I discussed, obtaining the clues from the environment in order to innovate the things. In order to innovate the things means in order to open up, that is in order to create the things. Innovate means create the things, that is obtaining the clues in order to create the things from the environment is nothing but biomimicry. Right. Sai Divya, sir, is NMR spectroscopy important? Yes, definitely NMR spectroscopy is important. And see, if you watch the 40 minutes video which I have made, you will get almost all the questions related to the NMR spectroscopy now. NMR spectroscopy, because see, in the NMR spectroscopy there is a much susceptible to ask the principle, right? Or MRI scanning, and MRI scanning is the same principle is involved in the NMR spectroscopy. The same principle is there in both of this, NMR and MRI. So if you watch that 40 minutes video, almost you will get all the terms as well as everything in the NMR. Just do watch that 40 minutes. That is very important, which I have made exclusive on NMR spectroscopy. So Aishwarya, hello sir, what happens if current stops flowing between 2 electrodes? So what happens means, it doesn't mean that, it means that that particular electrochemical cell is not functioning. That is the meaning. That's it. So when the electrochemical cell will not function, so when the salt bridge is removed between the 2 electrodes, so definitely the EMF is not going to be generated. And what is the important role of salt bridge? This can be asked in the exam student. The role of the salt bridge. The role of salt bridge means it is the one which is maintaining the electrical neutrality in between the 2 solutions. That is nothing but the salt bridge role. And this question is very important. Only odd number of electrons containing atoms like H1, C13, F19, P31 are NMR active, whereas C12 is not active. C12 is not active. F18 is not active. That is, whatever the atoms which are comprised of even number of protons are not NMR active. The reason is for the even number of protons containing atoms, spin quantum number is equal to 0. When the spin quantum number is equal to 0, then the spinning of that particular atom will not take place. So when the spinning of that particular atom takes place, then that particular atom will not get the magnetic nature, and for becoming the NMR active, definitely the atom should act as the magnet. So for which the I value should not be equal to 0, and the I value will not be equal to 0. I value will not be equal to 0 only for odd number of electronic containing atoms. Right. So what is laser ablation? Laser ablation is very simple, students. So what we need to do is we have to pass the Nd:YAG laser, right? So when we pass the Nd:YAG laser through the graphene, what happens is whatever the carbon content which is fixed in the graphene will come out and settles as the powder on the surface of the coolant. And whatever the carbon content which is coming out from the graphite and settling on the coolant is nothing but the carbon nanotubes. And why only Nd:YAG laser? I have clearly explained in the video. The reason is Nd:YAG laser, that is whatever the laser which is being used should break the strong covalent bonds which are holding the adjacent atoms in the graphite. Strong bonds will be there, students, and in order to break the strong bonds, definitely the strong laser is required, and that strong laser is nothing but Nd:YAG laser only. So Ajita Reddy, Sachin, what is laser ablation? I hope you got it. Ajita Reddy, yes sir, it is an information video. Thank you, Ajita. Sai Divya, watched sir, thank you. Okay, Abhinaya Abhi, Vanam Sham Prasad, hi. So some more questions. Thank you. Bhargav, sir, please explain band theory in solids. So band theory in solids, just it is conduction, the band that is energy between the conduction band and the valence band. That is nothing more to discuss about this. Already you studied in the lower classes also. The same you can write in the engineering. That depends only upon the energy gap between the valence band and the conduction band. So based upon the difference between the valence band or the conduction band, the conductant, one of the substance becomes the conductor, one of the substance become the semiconductor, one of the substance become the insulator. Tumbati Vamshi, hi. Bhargav, sir, please explain band theory. Okay, I hope you got it. Tumbati Vamshi, hello sir, how are you? I am fine, Vamshi. Fine, thank you. Next, Arlagada Bashwant Bhavan Raj, hi Bhavan. Explain about vibrational degree of freedom with examples. Right, this is a very good question, students, because this question has not been covered, because another sir has took the classes for you at while the NBA work. So degree of freedom is nothing but a number of variables. All of you listen, students, this is very important, and the questions can be asked based upon the degree of freedom. All of you listen carefully, just give a pause and listen carefully. The degree of freedom means the number of variables required to explain the molecule. Explain the molecule or compound is nothing but the degree of freedom. Is nothing but the degree of freedom. Right? I hope you got it. And only we have 3 planes. That is X, Y, and Z plane. Right? So the maximum number of degree of freedom is 3. Maximum number of degree of freedom is 3. And for the linear molecules, for calculating the number of vibration, it is 3n minus 5, where 3 is the maximum number of degree of freedom and n is the number of atoms. N is the number of atoms. And what is 5 in the case of linear? So 3n equals to transitional plus rotational. Transitional plus rotational. Transition is always 3, x to y, y to z, and x to z. Only 3 transitions is possible. So 3. Transition is always 3, plus in the case of linear molecule, in the rotation, how many rotations are possible? From left to right, right to left, left to right, left to right, right to left. So 3 plus 2, 5. So that is the reason 3n minus 5. Number of vibrations for the linear molecule is 3n minus 5. So whereas in the case of non-linear molecules, it is 3n minus 6. Why? 3n is common, 3 is number of maximum variables 3, and n is the number of atoms minus 6. Why 6? 3 is transition. And for non-linear molecules, left to right is possible, right to left is possible, and bottom is possible. So totally 6. So 3n minus 6. So for example, if we take HCN, the question is asked in the mid exam. HCN, the number of vibration possible in hydrogen cyanide. It is the linear molecule, HCN, HC triple bond N, right? So it is the linear molecule. So since it is the linear molecule, in order to calculate the number of vibrations in the linear molecule, what are required? That is, what is the formula? 3n minus 5. HCN. How many atoms are there? 3 atoms are there. So 3 into 3, 9 minus 5 is equal to 4. Right? I hope you got it. The Prakash explain about vibrational degree of freedom with examples. For example, methane, if you take, students, just methane is the linear molecule or non-linear molecule? Methane is non-linear molecule, so it is a tetrahedral structure. Now what is the formula applicable for explaining the number of vibrations in this? 3n minus 6. So 3 into n, number of atoms, carbon 1 and 4 hydrogens, totally 5. So 3 into 5, 15 minus 6. So 15 minus 6 is 9. 15 minus 6. Okay. Next, Abhinay, compression molding. Compression molding is nothing but just compressing. That is, in the compression molding, what we have to do is, we have to take the mold which is made up of the two halves, and the lower half should contain the cavity in the shape of the desired article. For example, if you want the bucket from the plastic, so the cavity shape should be in the same shape of the bucket. If you want any plastic paper or plastic cover, so the shape of the cavity should be the plastic cover, right? And what we need to do is, the upper half will contain the projection which can sit into the cavity, and after placing the upper half into the cavity, and in this cavity we have to take the polymer, that is, we have to take the plastic in this, and after placing the upper half into the lower half with the help of the projection, what we need to do is, just we have to subject it to the heat and the pressure. So whenever we subject it to the heat and the pressure, then strong bonding takes place between the upper half and the lower half, by which what happens, the plastic will takes the shape of the cavity. So if we want the bucket, the shape of the cavity is the bucket shape. If we want the shape of the telephone, like let us say that, it will be in the shape of the telephone, right? Compression molding, intrinsic and extrinsic conducting polymer. So intrinsic means, for example, if we take the polyacetylene, it is intrinsic conducting polymer. Why it is intrinsic conducting polymer? Because of the conjugation present in it, it is able to conduct the electricity. So it is happening internally. So since it is happening internally, the conductance is happening internally, it is intrinsic conducting polymer, right? So if we take the carbon black, right, so it is extrinsic. That is, we have to add some ingredient to that in order to make it as a conducting polymer. That is nothing but extrinsic, right? Korra Balaji Korra, hi. Alagada Bashwant Bhavanas, how does TMS minimize the effect of solvent or on chemical shift, sir? How does TMS minimize the effect of solvent? So because the TMS is nothing but tetramethylsilane and it is inert, unreactive. So since it is unreactive, it will not react with the solvent under any circumstances. So since it is not reactive under any circumstances with the solvent, it minimizes the effect of solvent on the chemical shift. VBA to 2K15. IT took hi, hello. So good to know your teaching has been reached all over. Thank you. Thank you. Who is this? May I know who is this? 2K15. Tumadi Vamshi, which was the preferable, sir, tea or coffee? Both tea and coffee, both are preferable, but only the thing is, yeah, whatever the tea or the coffee is, we have to take an adequate amount. We should not take more than 5 or 6 times. It is desirable to take the tea for 2 or 3 times daily, but instead of the tea, just go with the green tea, so which is very important uh, for our body. And what is the importance of the green tea, I will explain in one of my video. Right, thank you. Shravya Samavit, what is the reaction takes place when silver gets tarnished? Tarnishing is nothing but it is one of the corrosion only, student, but it is a dry corrosion. It is a dry corrosion. Whenever the chlorine gas is attacking the silver, then tarnishing of the silver, dry corrosion. And already I have said clearly that among the dry corrosion and the wet corrosion is the one which is the destroyer of the metal, but dry corrosion is preferable on the metal, but to some extent. So tarnishing is one of the dry corrosion, whenever the chlorine gas is attacking the silver. Next, sir, Veda Prakash, sir, how 15 to 6 will come, 15 to 5 will come? What is 15 to 6, Veda Prakash? 14 to 15, 66, 15 to 5? Can you explain again? Veda Prakash, what do you want? Vignesh Ujini, sir, explain application of nanomaterials in medicine. Vignesh, so medicine, just now I explained medicine, students. So this particular nanomaterials are basically used in the medicine as a drug delivery devices, and in the yesterday's class, in one of the class that is yesterday, that is dendrimers, while I'm talking about the dendrimers contains hollow shape, that is hollow cavities are there in that. So in that hollow cavity, what we need to do is we have to place the drug molecule containing the antigens, right, containing the antigens. So antigens will detect the cancerous cells once they are enter into the body, and detects the cancerous cells and kills only the cancerous cells without affecting the other healthy cells which are a part of our body. That is about the application of the nanomaterials in medicine. And coming to the application of nanomaterials in catalysis, so already I said that the nanomaterials, if the bulk material is converted to the nanomaterial, the surface to volume ratio is increased now. So surface to volume ratio is, for example, just take the sugar, right? Take the sugar, one spoon of sugar, right? It is the bulk material. Now crush it into the powder. So just to see the quantity of the sugar. The quantity is not changed, students, but the thing is, whenever it was the bulk material, what happened? The surface to volume ratio was less. So whenever it is converted to sugar, then surface to volume ratio will increase. Just take any substance and crush it to the powder, then the volume will increase. So when the volume increases, then the surface to volume ratio increases. Definitely it can be used as a good catalyst. And for acting as the good catalyst, the criteria required by any of the substance is, so to have the good surface to volume ratio, friends. And in environment, for photovoltaic cells it is used, fuel cells it is being used, and in some of the fabrics it can be used, that is which are which are resistant to sweat, which are resistant to heat, which are resistant to water, everything, and that are yet to come in the market, that are yet to be commercialized. Kottakonda sai condition for combining atomic orbitals. Condition for combining atomic orbitals is symmetrical atomic orbitals combined, students. that is 1s, that is ss possible, sp is possible, but the difference should not be more. For example, 1s is there and 6x is there. This possible combination is not possible. The energy difference should not be more. So 1s 2s is possible, 2s 2p is possible. Nearby energy is there. Next 2p, next 3s is possible, like this, right? And symmetric, right? sp is possible, px is possible. That is, both should be either vertical, or both should be either horizontal. This is symmetrical, this is possible. Next, Shravya, what is the reaction takes place tarnished finished? Venkat, Sai, Chiran, Sir explain about carbon nanotubes and carbon nanowires, and this is the theory subject. Please, if you study this, you will get it. So already I have explained in the classes also, in the previous class also. Carbon nanotubes are very lighter in weight and stronger in, but already I have discussed in one of the class, that is classification of the nanomaterials, that it is 4 times stronger than it is 4 times stronger than the steel, but it is very light, very light. And this carbon nanotube are sp2 hybridized, that is sp2 hybridized carbons are present, and because of this it can even act as a good conductor also, right? Not only that, already I have clearly explained, these can be act as the good antioxidants because of the more number of electrons present in the carbon nanotubes as well as the fullerenes. Sir, explain the carbon nanotubes and carbon nanowires. Will be batch team IT2K15. I hope you remember us. You were our class teacher. Okay, I have remembered. Thank you. But can I know what is the name of you, right? Tumbade Vamshi sir, instrumentation. What is there in the instrumentation? The source of the light will be there. Next, monochromata will be there, right? In everything, source of the light. Monochromata is exclusively involved in UV visible spectroscopy. Because why in the UV visible spectroscopy is monochromata is required? The reason is in the UV visible light is comprised of the 7 colors, 50R. But based upon the color, this UV visible light should be incidented on the sample. For example, let us say that the sample which we are going to take is our red color sample. So if the sample is red color, then this polychromatic light should be converted into the monochromatic light. That is, that light which can be observed only by red color, filtering all the remaining, that is V, I, B, G, Y, O. So these 6 should be filtered. The 6 should be filtered. Only red colored light should be passed. For example, the color of our sample is violet. Now what we have to do? Polychromatic light contains all the colors, 7 colors. So it should be converted to monochromatic light, and the monochromatic light should contain only the violet color radiations. So it should filter the remaining I, B, G, Y, O, R, like that. Next, the sample will be there. Next, followed by the detector, followed by the amplifier, followed by the recorder. So what will be the detector will do? It will detect the electrical signals in the form of the spectrum, and that is being recorded, that is being amplified, because whatever the signals we are going to get, they are very light, they are thinner, where they are thin. So since they are thinner, so definitely we need to sharpen them. We need to amplify them in order to record this, in order to read the spectra properly. So that is the reason amplifier is being used. So finally, so in the recorder, it will be recorded as a spectrum. Next, sir, instrumentation, Veda Prakash, degree of freedom. Okay, Veda Prakash, degree of freedom. The number of variables required for explaining the molecules. The number of degree of freedom variables required for explaining the movement of the molecules is nothing but degree of freedom. And how many maximum number of variables can be there? Only 3: x axis, y axis, and z axis. So maximum number of variables is 3, right? 3. And for calculating the number of vibrations in the case of linear molecules, the formula is 3n minus 5, already discussed. And for calculating the number of vibrations in the case of non-linear molecules, it is 3n minus 6. What is n? Number of atoms. For example, if we take hydrogen fluoride is HF, right? So whether it is a linear molecule or non-linear molecule. So it is a linear molecule, right? So since it is a linear molecule, right? So how many number of vibrations, in order to calculate the number of vibrations, what is the formula for the linear molecule? 3n minus 5. So 3 into number of atoms, HCl. How many atoms are there? Only 2 are there. So 3 into 2, 6 minus 5. 6 minus 5, 1. For example, methane is there. Methane is non-linear molecule. So what is the formula for calculating the number of degrees of freedom? 3n minus 6. 3 is common, 3 dimensions. N is number of atoms. How many atoms are there in methane? Carbon 1, 4 hydrogens, 5. So 3 into 5 minus 6. 15 minus 6, 9. Like that. So first you have to find out whether it is a linear molecule or non-linear molecule, students. Right. Next, Gopi sir, FRP please. Gopi Kishore, degree of freedom, Kiliveru. For methane, okay. Methane is non-linear, just I have discussed. Methane is non-linear, it is tetrahedral in shape. So it is non-linear. So since it is non-linear, the formula for calculating the number of vibration is 3n minus 6. So 3 into n, 5 atoms. How many atoms are there? N is nothing but number of atoms. So 3 into 5, totally 15 minus 6, 9. Gopi Kishore, sir, FRP please. Gopi Kishore, what is FRP? Just tell me what is FRP. Okay, fiber reinforced plastic, right? Thank you. Okay, fiber reinforced plastic is the plastic which is reinforced by the addition of the fiber. And the most extensively used fiber for reinforcing or strengthening the plastic is the glass fiber because of its durability, high durability. Next is it is acid proof, waterproof and fireproof. Next, Gopi Kishore, Ravi Nayak, super sir, thank you. Crystal field splitting of orbitals. Crystal fields, whenever the molecule or the complex is placed in the crystal field, then splitting takes place according to their geometry. If it is octahedral, the splitting is different. If it is tetrahedral, the splitting is different. If it is square planar, it is different. And already clearly explained, it's a very broad topic. Please, you have to study it. Okay. Next, Nitin Kumar, hi. Gopi Kishore, sir, also rotaxanes. Topic is there. It is not there in the syllabus, it seems, right? So VBIT, Ravi Teja, sir. Hope you remember. Oh, Ravi Teja, okay. Ravi Teja, right, good, Nana. How are you, Ravi? After a very long time. Huh? Thanks for coming. Next, Tummati Vamshi, sir, Beers-Lambert's law. So exclusively I have made the Beers-Lambert's law, Nana. Beers-Lambert's law is when a beam of monochromatic light is passed through the sample, then the light absorbed by the sample is directly proportional to path length and concentration, path length of the absorbing medium and concentration of the solute present in the solution. That is nothing but Beer-Lambert's law. And in order to understand the Beer-Lambert's law, I have clearly explained in one of the video individually Beer law and Lambert's law. Beer-Lambert's law is nothing but when the beam of monochromatic light is passed through the sample, then the light absorbed by the sample is directly proportional to path length of the thickness absorbing medium. Path length means thickness of the absorbing medium and the concentration of the solute present in the solution. Magavat Anil Kumar, thank you sir for instrumentation. Thank you. You're welcome, Anil. Rajkumar, sir, FRP, fiber reinforced plastic. Fiber reinforced plastic means the plastic which is reinforced by the addition of the fiber is nothing but fiber reinforced plastic. And in order to prepare the fiber reinforced plastic, so definitely we have to choose the plastic in such a manner that it will not wear and tear away with the addition of the fiber, because all the plastics are not resistant to the addition of the fiber. For example, polyethylene. So polyethylene is not resistant to the addition of the fiber. So if you add the fiber to the polyethylene, then wearing and tearing means it gets destroyed. So that is the reason the fiber reinforced plastic is only made by the plastic, made on the plastic which is resistant to the addition of the fiber, like polyester thermosetting plastics like polyester, nylon 66, bakelite, like that. Next, Ravi Nayak sir once explained high energy ball milling. High energy ball milling, clearly I explained in one of the video. Ball milling is nothing but with the help of the steel or the tungsten balls. With the help of the steel and tungsten balls, we are going to crush the bulk materials into the nanomaterials. That is the basic concept in the ball milling. And why it is called as high energy means during the grinding of these bulk material particles with the balls, what happens is the friction between the balls and the bulk powder takes place. So due to the friction between the balls and the bulk powder, then high energy is generated. So that is the reason the ball milling method is also called as high energy ball milling method. Next, Nikki High. Sai Kumar, determination of pH using glass electrode. So for the determination of pH using glass electrode, just what you need to do is on one side glass electrode and the other side you have to place the saturated calomel electrode, right? And in between these two, salt bed should be placed, and EMF equals to, what is that? E RHS minus LHS, E cathode minus E anode. Always cathode is saturated calomel electrode, reference electrode only, already have explained. So EMF equals to, what is the electrode potential value of standard electrode potential of saturated calomel electrode? 0.2415 minus E naught minus 0.059 pH. So by rearranging the equation, you will get the information about the pH of the solution making use of the glass electrode. Thank you from all the students of YT. Thank you, Nana, Ravi. Tomadi Vamshi, good night, sir. Sweet dreams. Vamshi, good night to you. Thank you and welcome. Next, Podishetty Sanjay. What is the difference between CVC and CVD? I have explained in the video what is the difference. Right? So the main difference is, in the case of CVD, chemical vapor deposition, we are going to prepare the thin films. Whereas in the case of CVC, chemical vapor condensation, we are going to prepare the metallic and ceramic nanomaterials. The main difference is, in the case of the CVC, the gas flow is being controlled. Gas flow is controlled, right? And the temperature releasing equipment is different when compared to CVC and CVD. So three differences are there, are clearly explained in the video. Right, main difference is CVD, that's chemical vapor deposition method, prepares the thin films, whereas CVC, chemical vapor condensation, prepares the metallic and ceramic nanomaterials. Tumati Vamshi, good night. Okay, Tumati Vamshi, bye. Bye, Nana. Sai Divya, please explain chemical vapor condensation. Divya clearly explained each and everything related to chemical vapor condensation. Please do watch a video on that. So it is just 15 minutes, because within this time I cannot explain the chemical vapor condensation, and the principle involved in the chemical vapor condensation is similar to the gas condensation processing. gas condensation processing, that I can say that. But please do watch. It is the video is made only for 15 to 17 minutes. Do that video, you will get the complete information about CVC. So Bodhishetty Sanjay, what is the difference? Okay. Tumbadi Vamshi buys chemical vapor condensation. Valluri Naveen, hi sir. Hi Nana. Please explain degree of freedom. Just now explained, Nana. Degree of freedom is number of variables required to explain the movement of the molecule. So mainly we have the 3 x, y and z. So 3. So maximum number of degree of freedom is 3. The number of variables required to explain the rotation of the molecules or the movement of the molecules is called degree of freedom. Next, Kiran Karnati, hi sir, what is pitting corrosion? Pitting corrosion, just now I said, Nana, pitting corrosion is nothing but the corrosion. It is one of the wet corrosion which is formed due to the development of tiny pits or holes on the surface of the base metal. And what is the base metal? Already clearly explained that base metal is the metal which is more susceptible to undergo the corrosion. So in the corrosion you have to remember the 3 types of metals, Nana. The one is the base metal. Base metal is the one which is going to undergo the corrosion. That is, the base metal is the metal whose corrosion is to be controlled. That is base metal. Next, active metal means the metal which is more active towards corrosion when compared to the base metal. Now coming to the third type of metal in the corrosion is noble metal. The metal which is cathodic in nature compared to the base metal is nothing but the noble metal. So Alluri Naveen, okay. Kannati, Gopi Kishore, pitting corrosion means when a metal was rubbed by other metal, there are some pits formed due to the corrosion occurs. That is Gopi, that is not the exact definition. So pitting corrosion doesn't mean that pitting corrosion means when a metal was rubbed by other metal, not like that. So see, whenever the metal is placed in the environment, so definitely the environment is comprised of the so many electrolytes, like for example, let us say that one drop of sodium chloride is resting for a long duration on the surface of the metal. Under the influence of that particular water droplet which is settling on the surface of the metal for a longer duration, pit is developed. Pit is nothing but the small hole is developed or small crack is developed. With the help of that particular small crack or the hole, interface of the corrosion starts. Interface of the corrosion opens. And what is the interface? Already I have discussed. Interface of corrosion means the doors are open for the corrosion to occur. So once the doors are open for the corrosion to occur, so definitely it will undergo the corrosion. And whether it is the hydrogen evolution corrosion or oxygen absorption corrosion, that is decided by the corroding medium. That is whether if the substance which is resting on the surface of the metal is acidic in nature, then the hydrogen evolution corrosion takes place. If it is slightly basic or neutral in nature, then oxygen absorption corrosion takes place. Gopi Kishore, just don't be under the impression that whenever the rubbing of the metals takes place, then the pitting corrosion takes place. Okay, that is one of the case, but it is not the actual definition. That is, whenever the electrolyte settles on the surface of the metal, under the influence of that electrolyte, the holes or the pits are going to be formed after some time on the surface of the metal. Valluri Naveen, thank you sir. Thank you, Anna. Welcome. Cathodic protection. Cathodic protection is nothing but the main. For example, see, when the metal undergo the corrosion, whenever it acts as anode and whenever it acts as anode, or whenever it acts as the cathode, whenever it acts as anode. Whenever it acts as anode, it undergo the oxidation, and oxidation is nothing but the corrosion. Now, whatever the metal whose corrosion is going to be avoided or protected is to force to act as a cathode instead of acting as an anode. So if it is forced to act as cathode, now instead of acting as anode and undergoing oxidation, oxidation is nothing but corrosion, it now undergo the reduction process, that is nothing but cathodic production. And cathodic production can be done in two ways: sacrificial cathodic production and impressed current cathodic production. Sacrificial cathodic production means the base metal is attached to the more anodic metal. Now instead of our base metal, the more anodic metal act as anode and undergo oxidation, and whatever the metals which are at the top in the galvanic series or the sacrificial anodes, for example magnesium is attached to the lead pipeline which is buried under the ground. So whenever it is attached to the lead pipeline which is buried under the ground, then instead of this lead, now the magnesium act as anode and undergo oxidation, that is nothing but corrosion. And in the impressed current cathodic protection, so we are going to force the electrons to the pipeline. Whenever we are going to force the electrons to the pipeline, then the lead pipeline, which is more anodic actually, now by gaining the electrons, it will act as cathode instead of acting as anode and undergo oxidation. Next, Veda Prakash Shilivaru, sir, important topics in corrosion. So very important topic in corrosion is wet corrosion, and the mechanism of wet corrosion. Wet corrosion means not only the wet corrosion. You are not supposed to write the corrosion occurs under wet conditions or due to the development of electrochemical cells is nothing but the wet corrosion, right? ಅದು ರಾಸ್ತ ರಾದು ಮೊತ್ತ ಮಾರ್ಕ್ಗಳು ರಾವು. Mechanism of wet corrosion. What is the mechanism of wet corrosion? That is hydrogen evolution corrosion and oxygen absorption corrosion. So the question can be asked in this manner, that is, what is wet corrosion, and explain the mechanism involved of wet corrosion or electrochemical corrosion. And the other way to ask this question is, explain the electrochemical theory involved in rusting of iron. So this is very, very important. The next one is cathodic protection, sacrificial anodic protection, and impressed current cathodic protection. Galvanization is very important. Next, electroless plating is important. I'm not saying that the other questions cannot be asked, but they can be asked in the exam, but these are very important when compared to the other one. Next, Badavat Balakishore, sir, what is NMR? NMR is nothing but nuclear magnetic resonance. Why it is called as nuclear magnetic resonance, I have clearly explained in the video. Raju Chetla, superb Shrishan. Raju, how are you? Raju, ela unnana bagunara? Raju. Gopi Kishore, okay sir, thank you. Chandrasekhar, hi. Hi Nana. Sri Chandra Vikas CH, hi sir, hi. Gopi Kishore, sir, explain the N-type intrinsic conducting polymer working principle for conducting N-type. So see students, N-type and P-type both are there. N-type and P-type. That is, so I already have said that due to the presence of the conjugation in the polyacetylene, and this conjugation involves the pi electrons, and as the pi electrons are flexible in nature, and due to the movement of this flexible pi electrons, then they carry the electrons along with them whenever it is placed in the electrical field. Already said that. But in order to fasten that is, in order to speed up the movement of the electrons, we have to do the doping process. So in N-type means what? Whenever we have to expose the conducting polymer to the oxidant. Whenever we expose the conducting polymer to the oxidant, what is oxidant? Oxidant is a substance which oxidizes the other, thereby itself undergoes reduction. For example, if it is exposed to the iodine, so what the iodine will do? It oxidizes the conducting polymer. What is the conducting polymer? Polyacetylene. That is, loss of electrons takes place from the polyacetylene. Whenever the loss of electrons takes place from the polyacetylene, then positive charge is created on one of the carbon of the polyacetylene. positively charged carbon is not stable, students. Either positively charged carbon is not stable or negatively charged carbon is also not stable. It's not stable. So it should be remained as neutral in order to get stabilized. So positively charged is not stable. So since it is not stable, in order to stabilize the positively charged carbon atom which has been developed by the oxidation under the influence of the oxidant which is the iodine, these pi electrons move very fastly towards that positively charged carbon atom in order to stabilize it. That is nothing but n-type doping. So p-type doping means what? Exposing the conducting polymer to the reductant. What is a reductant? A reductant is the substance which reduces the other, thereby itself undergo oxidation. That is, reduction takes place. Reduction takes place means what? The gain of electrons takes place. So gain of electrons means one of the carbon gets a negative charge on it. That is, in the polyacetylene, one of the carbon will get the negative charge on it. Already I said that carbon is not more electronegative to bear the negative charge. So since it is not more electronegative to bear the negative charge, it is unstable. So since it is unstable, now these excess electrons, negative means what, students? Excess electrons which have been generated inside on the carbon, that is on the carbon, will enter inside the ring, fastening the movement of the pi electron. So fastening the movement of the pi electrons means what? The speed up of the movement of the electrons takes place. So speeding up of the movement of the electrons means what are the electrons in this? Electrons are the charge carriers, right? So as the movement of the charge carriers is speed up, then definitely it conducts more electricity when compared to the normal conducting polymer. That is P and N type of doping, N and P type doping. Right? I hope you got it, Gopi Kishore. Rahul Gaud, what are the important topics in spectroscopy, sir? Now the important topics spectroscopy lo all are important. The reason is the spectroscopy unit contains 14 to 15 pages. Only 14 to 15 pages ఉన్నాయి. ఆ 14 to 15 pages ఇంపార్టెంట్ అంటే నేను ఏం చెప్పాలి, ఏదైనా రావచ్చు, it depends. Okay, so you have to study each and everything in the spectroscopy. ఏమున్నా what are there in that? Just what is spectroscopy? What is, for example, UV visible spectroscopy is there. UV visible spectroscopy. Next, instrument principle, instrumentation, terms involved in it. Next, selection rules. Next, application. The same thing is there in all the spectroscopies. So Nana, chadu mottam chadu Rahul. Next, K Varad, hi Varad. Next, Sai Kumar, differential aeration corrosion or concentration cell corrosion. Both are one and same Nana. Differential aeration corrosion and concentration corrosion, both are same. That is, whenever the metal part is exposed to varying concentration of oxygen, that is, half of the metal is immersed in the water and half of the metal is exposed to the air. The one which is more aerated act as cathode and undergo reduction, forcing the metal which is present inside the water to act as anode and undergo oxidation. Oxidation is nothing but corrosion, and this oxidation or corrosion won't happens opens on the metal which is totally dipped in the water. So it will only takes place just above and beneath the water line. That is the reason it is also called as waterline corrosion, because whenever whatever the portion of the metal which is totally immersed in the water is homogeneous in nature. So since it is homogeneous in nature, and already for undergoing the wet or electrochemical corrosion, definitely heterogeneity is required, right? Heterogeneity is required. So heterogeneity is there on the water line only. Just above the water line, it is more aerated. Just below the water line, it is less aerated. So heterogeneity is there. So if the heterogeneity is there, then only the metal undergo the wet or electrochemical corrosion. Pavan Kumar, hi Professor, nice explanation. I am following your lecture. Thank you. Dr. Professor, Bonara sir. Thank you, Pavan. Vamshi Naik, high energy ball milling method. Just now I explained, ball milling method is nothing but crushing the bulk powder with the help of the balls. With the help of the balls, either they are made up of the steel or wolfram carbide balls, crushing it. And crushing the bulk powder to the nanomaterials is nothing but the ball milling. So since it is utilizing the balls either made up of the steel or the wolfram carbide, so that is the reason it is called as ball milling method. And during this crushing process, what happens is the friction takes place between the balls and the bulk powder particles. Due to the friction, high energy is generated. So since high energy is generated, this particular ball milling method is also called as a high energy ball milling method. Right, hope you got it. Next, Veda Prakash, sir, how to remember Becquerel mechanism? Becquerel mechanism is very simple, Anna. It is phenol formaldehyde resin. So phenol formaldehyde resin means one of the reactant, one of the starting material is phenol and the other one is formaldehyde. What is phenol? Benzene with OH group. What is formaldehyde? HCHO. Now HCHO, this reaction between the phenol and formaldehyde takes place in the presence of acid H+. So HCHO, CH2O of this formaldehyde react with H+ of the reagent CH2OH. Now write down the same phenolic 2 moieties as the products. Now place the CH2OH at ortho position. What is ortho? Already you know that. First position with respect to substituent. And place the CH2OH at the para position. Para position means third position with respect to CH2OH. Now the second step is place the phenolic moieties and orthohydroxy methylphenol, because orthohydroxy methylphenol is a major product. Why it is a major product? Because of the hydrogen bonding. I don't want to explain in detail again. So due to the hydrogen bonding, it is more stable. So always the major product will lead the further reaction. So place the phenolic moiety and the orthohydroxy methylphenol moieties in such a manner that H and OH are visible to us. So remove the water molecules. After removing the water molecules, you will get phenol moiety followed by CH2. Phenol moiety followed by CH2. Phenol moiety followed by CH2. Now this is nothing but linear polymer, and always the linear polymers are not strong. So since linear polymers are not strong, there is a need to convert the linear polymer into cross-linked polymer, for which we have to add hexamethylene tetraamine for this Novolac moiety. So when the hexamethylene tetraamine is added for the Novolac moiety, then the bridge takes place between the two Novolac moieties with the help of CH2. Now in order to get the structure of the Becquerel from the Novolac, what you have to do is just place one Novolac moiety at the top and take its water image. And in between these two, place the CH2s. So phenol, CH2, phenol, CH2, phenol, CH2. That is the Becquerel. Right. Argalal Pawan Raj, is the question bank you have given is enough for the SEM exam, sir? Pawan Raj, initially I have said before starting this session that the question bank, whatever given, have give is important. Whatever the questions which are a part of the question banks are important. It doesn't mean that only these questions will be appeared in the exam. There is no guarantee. But only the thing is, when compared to other topics, these are important from the examination point of view. So first complete this question bank. Once you complete this question bank, which comprises of important questions, then you start reading the other questions. I hope you got it. Sanat Kumar Jaini, sir, selection rules for UV and IR. So selection rule is common. It's very simple. Selection rule means what? Whenever the electromagnetic radiation is passed through the molecule or the sample or any substance, it doesn't mean that all the electromagnetic radiations are observed by the sample or the molecule or the species. It is guided by some of the rules. So So those rules which acts like a guidance for the absorption of the electromagnetic radiation by the molecules or sample or species is called as selection rule. And selection rules are different. Spinning pattern should be same, triplet form should be same, singlet. So if you read it, you will get it very easy, simple. Only the thing is, selection rules means they are the rules which guides the absorption of the electromagnetic radiation with the sample or molecule or molecule or species. Biomimicry, biomimicry examples, sir. So biomimicry examples are gecko. So gecko is one type of lizard, that is, it belongs to lizard family. So gecko can crawl on any surface, whether it is a smooth surface or any surface, it can crawl. Right? So based upon that, we can say that it is having the adhesion nature. So based upon the adhesion nature of the gecko, that is based upon the adhesion nature of what? Its legs, adhesion of it, right? So that fascinated the scientist in order to prepare the adhesives. Gecko is one of the example. For adhesive. Gopi Kishore, but sir, in p-type, the delocalized electrons will jump bands when they are subjected to external field, but in 10-type, the electron will not jump the band since they have energy way settled in gap. Electrons will not jump, Gopi. It doesn't mean that they are jumping. The electrons are shifting. Jumping is different from shifting. The shifting of electrons is taking place from one atom to another atom. That is the meaning of the delocalization of electrons, not jumping. So valence band and conduction band is there, but only the thing is, here we have to focus only on the shifting of electrons from one atom to another atom. Then comes the difference between the valence band and the conduction band. First focus on this. Just focus on this rather than the conduction and valence band. Just focus on the positive charge created on the carbon and negative charge created on the carbon. If the conducting polymer is exposed to the oxidant, then positive charge is created. If it is exposed to the reductant, then negative charge is created. Just focus on this. Then shifting of electrons, because shifting of the electrons or delocalized of the electrons is the one which are responsible for the conduction of the conducting polymer, students. Just a moment. Right, next, Gopi Kishore, my lecture did not clarify me. My lecturer, okay. It's okay, Gopi. Only just you focus on the positive and negative charge, because the carbon is neither more electronegative can to bear the negative charge in it, nor too low electronegative to bear the positive charge in it. So always it wants to be in the neutral form. So definitely, if the positive or negative charge is created on the surface of the carbon, so definitely the electrons will move readily towards that positively charged carbon atom in order to neutralize it. On the other hand, the negative charge is created on the carbon means it is electron efficient, but the carbon is not too electronegative to bear the electrons on, that is negative charge on it. So negative charge means extra 2 electrons. Those 2 extra electrons will participate in the delocalization. When the delocalization of the electrons increases, conductance increases, because the conductivity of conducting polymer is basically attributed to the what? The delocalization of pi electrons. I hope you got it, Gopi. Next, Veda Prakash. Thank you, sir. Had a great session. Welcome, Nana. Sai Kumar. We had a good session. We are welcome, Nana. Sai Kumar, thank you. Can I see your son? Shashrik? Shashrik? చూసారట వాళ్ళు పిల్లలు. సో హీఈస్ మై సన్. సాయి చూసావా? హాయ్ చెప్పురా.
హాయ్ హాయ్
హాయ్. ఓకే చూసావా? రైట్. బాయ్ చెప్పేసి.
బాయ్ బాయ్
అబ్బాయి అబ్బాయి బాయ్.
బాయ్
అదో మనీషా. హాయ్ శశ్రీకంఠ. హాయ్
హాయ్
చెప్పు.
హాయ్
ఓకే హాయ్ హాయ్ బాలకిషోర్ సార్. కెన్ యూ ఎక్స్ప్లెయిన్ అబౌట్
Hi.
బ్యాటరీ? చెప్తానన్న. గోపి కిషోర్ హాయ్ చెప్పు.
హాయ్
హరిత సన్ ఇస్ వెరీ క్యూట్ సార్. క్యూట్ అంట. థ్యాంక్ యూ చెప్పు.
థ్యాంక్ యూ
సో థ్యాంక్ యూ ఎవ్రీవన్. ఇంకా వేదప్రకాష్ హాయ్ శశ్రీకంఠ. వేదప్రకాష్ అన్న హాయ్.
హాయ్ హాయ్ అంకుల్
అంకుల్ కాదురా అన్న.
హాయ్ అన్న
రైట్. అశ్రిత ఈజ్ సో క్యూట్. హాయ్ హాయ్
Hi.
అశ్రిత. అశ్రిత హాయ్.
హాయ్ బాగున్నారా? గుడ్ నైట్ బాయ్ బాయ్ బాయ్.
Next, Balavat Balakishore, sir, can you explain about batteries? So, battery is nothing but the composite. Composite means what, students? Composite is nothing but composite is the combination of so many electrochemical cells is nothing but the battery. The combination of so many electrochemical cells is nothing but the battery. And there are two types of batteries. The one is primary battery and second one is secondary battery. So primary battery means the battery which cannot be rechargeable, that is primary battery. The battery which can be rechargeable is nothing but secondary battery. So examples of the primary battery: alkaline battery is there, lithium battery is there. And one more, student, one thing I want to say again: lithium battery means primary, lithium ion battery means secondary, lithium cell means primary, lithium ion cell means secondary. Don't be get confused in the exam. Have you got it? Suspension polymerization. Actually, suspension polymerization is not there. Gopi Kishore, can you tell me which university you come under? Gopi. JN2K, Kakinada. Okay. Suspension polymerization is not there in the syllabus, but the suspension polymerization is just, I hope it is the combination of the suspended particles. Just give me the clue. I will give the explanation about suspension polymerization, because I never heard about the suspension polymerization. Kottakonda Sai Kumar. Hi, like hero, like you said. Okay. Thank you. Gopi, just give me the clue for the suspension polymerization. I will tell what is it. Because it's not there in JNTU or Usman University also. It is not there. Suspension polymerization. Bye, Jibandar.
Bye. Good night. Bye bye.
Right, Nana? Okay. So some tips I want to give to you in the exam. That is, students, one thing is, write the answer according to the weightage of marks. If it is 2 marks, the pattern is 2 into 5. It is 2 into 5 in this 2. From each lesson, right? From each unit, you are going to get the two short questions, 2 into 2 4, so totally 5 are there, 5 units are there, 4 into 5 or 20. And coming to the section B, so you're going to have 10 marks questions. You are supposed to write A, B or C, D. So once again I am saying to you, right, that just focus on either A, B or C, D. Don't write A, C or B, D. You are not going to get the marks. If you write the complete answer, or if you write the answer so precisely also, you are not going to get the marks, right? So do the choice that is very important. I either choose A, B or C, D students. And to how much extent the question is being asked, write down that thing only, because the time constraint is very important, and the chemistry is very vast, and not only that, the topics are lengthy. So since the topics are lengthy, so please try to adjust the time. So without adjusting the time, you cannot manage the timing, right? So Gopi Kishore, I did not understand it properly. Light concept, whatever it is. Okay, Nano. Actually, the suspension polymerization is not there in Usman University as well as in JNTU Hyderabad. So I will go through it, and if possible, I will make the video. And tomorrow, when you have the exam, Gopi, let me know. BSS Gupta Jagdish, how are you, sir? Fine. Who is Jagdish? Tapanda Sai, Tinandi said it's too late. Okay. Shall we wind up? Already 10-20 students on 20th Jan. Okay, 20th Jan means definitely I will try to make the video on suspension polymerization. Okay, don't worry about Gopi. And if you want any sort of the topics, please do comment in the comment box. I will make the videos for you. Don't worry. Okay. And NVSS Gupta Jagdish, do you remember me, sir? Haven't remembered Jagdish. So let's find out. Okay, Nana, Sai, bye. Gopi Kishore, heartfully thanks, sir. It's okay, Gopi. So just whatever the topics you feel uncomfortable, just comment me in the comment box. Definitely I will make for you exclusively, right? Jagdish, okay. Jagdish, which college are you from? SV college or from BBIT? Give me the Jagdish, sir, I loved most is yours videos. So no, I couldn't remember Jagdish. Just can you tell me who are you? Sai Kumar, bye, good night. Sai, bye, Nana. Gopi, bye. Jagdish. Now, where are you, Jagdish? I am your YouTube video student. YouTube video student. Okay. Can I know from which university you are? I am from Vizag, sir. Okay. Vizag. So SV University, right? SVU or Kakinada, JNTU Kakinada? I am from Gayatri Vidya Parishad. Okay, Nana. Okay, nice to see you. Abhilash Reddy, hi sir, Abhilash Reddy from SV College. Oh, you remember us. Okay, Abhilash, I remembered. How are you? Abhilash, what are you doing now? Sai Prakash Bachu, red shift and blue shift. Chaptana, how, Abhilash? What are you doing now, Abhilash? Red shift or blue shift? So red shift is nothing but bathochromic shift, blue shift is hypsochromic shift. That is, bathochromic shift means shifting towards red color. And blue shift means shifting towards blue color. That is, red shift or bathochromic shift is an effect by virtue of which the absorption maxima shift towards longer wavelength towards right, VIBGR, right, VIBGR or red towards right, longer wavelength. And blue shift means it is an effect by virtue of which the absorption maximum, that is lambda max, shift towards blue side, blue, that is shorter wavelength, VIBG or VIB, that is red shift and blue shift. Gopi Kishore sir, can I know what are chapters you are covering in your university? Okay, so one is theories of bonding, and the second one is nanomaterials. Next is electrochemistry and corrosion. The next one is polymers, and the final is spectroscopy. Okay, Abhilash, where are you, Abhilash? Guru Sai, I am from BBT. Which branch, Guru Sai? Abhilash Reddy, Hyderabad. Okay, good, Nana, good. I hope your batchmates are doing good, right? Abhilash Reddy. Sai Siddhartha, square plane complex fitting concept. Sai Siddhartha. Square planar complex is just like the octahedral. Octahedral splitting takes place first. That is, the T2G orbitals will occupy the lowest energy level. EG orbitals occupy the highest energy level. Next, further splitting takes place. So dx square minus y square and dz square, right? Further splitting takes place, and dz square will occupy the highest energy level, and dx square minus y square occupies the lowest energy level. Further splitting takes place because in this particular square planar splitting, the electrons repulsion is not there in the z-axis. Just to go through it, I may have made the video on it also, because I cannot explain in detail about the square planar list within short time, because this is the broad topic. Just go through the video. Abhilash Reddy is Hyderabad. Abhilash Reddy, yes sir, everything is good. Gopi sir, good night Gopi, and don't forget to comment in the comment box whatever the topic you are there, and whatever the difficulties you are facing in the chemistry, you can comment in comment box. Definitely I will make the videos. Okay, don't worry about the chemistry. Okay, because chemistry is a mystery without the concept. I know that very well. So can we wind up, Ajita Reddy? Okay, thank you for an enlightening session, sir. Thank you, and all the best for the exam. Do well in the exam and study well, prepare well. Shall we wind up the session, students? Harshavardhan Yadav, sir, who are going to correct our SEM exam paper. So, who are going to correct, I don't know, but we are not going to correct your papers. Okay. Veda Prakash, thank you, Nana. Welcome. Nitin Kumar, give the principle of UV visible spectroscopy. Principle is very simple. Whenever the UV visible light is irradiated on the sample, then electronic transitions takes place in the molecule. So those electronic transitions are nothing but the excitation of electrons from the ground state to excited state is nothing but electronic transition. That is the UV visible spectroscopy. That is principle. That is, whenever the UV visible light is irradiated, then electronic transition takes place in the sample or the molecule. Shall we wind up? Just tell me good night if you want to wind up, students. Sir, when will we interfere in live blog, sir? Live blog, I don't have the idea because for my students the exams is going to be finished on Monday. Just we can have a live chat. Okay, I will try to arrange the live chat for the other students. The Prakash. So once again, thank you for the session, sir. Thank you, Nana. But only the thing is, you have to perform well in the exam. That's the reason for making this particular session. Okay, you have to do good in the exam. Otherwise, it is waste of all this sessions, all that. It's waste of my energy and your energy and your time and my time if you are not going to perform well in the examination. Nitin Kumar, some applications of IR spectroscopy. So applications are of IR spectroscopy is it is used to identify the functional group present in the molecule. That is the first case. It can differentiate the geometrical isomers. It can be used to elucidate the structure of the macromolecules such as vitamins, macromolecules like the carbohydrates, so many molecules. Okay. You can write anything, but especially mainly this particular IR spectroscopy is used to determine the functional group present in the molecule. That is the main advantage or application of the IR spectroscopy. The remaining, the same applications what are there, what you wrote for the UV visible spectroscopy, the same thing can be reflected here as well. Gopi Kishore sir, when will the Prakash once again, right? Some application of IR spectroscopy. Rahul, thanks for your enlightening session. Rahul, thank you, and I hope you're going good and just prepare well, Rahul. I'm expecting the good results from the IT students and triple B students, my students, right? You have to get the good results and with the not only pass. Okay, you're not going to get. You're not supposed to get the pass marks only. You have to get the good marks in the examination. You have to do well in the chemistry exam, especially being a chemistry faculty, right? So I'm not saying that you are not supposed to do good in all the remaining exams. You are supposed to do good in each and every exam, but the only thing is, so do excellent in the chemistry exam. Thank you so much, sir. Jennifer Bhupesh, yes, sir. So acknowledge. Okay, shall we wind up, students? Just those are watching, please just tell me bye or good night something. So more 10 people are watching. Otherwise, I will wind up. Veda Prakash, okay, sir. Good night. Okay, good night, Veda Prakash. Good night, Nitin Kumar. Gopi Kishore, bye bye. MSS Gupta, Jagdish, good night, sir. Good night. Raj Kumar, thank you so much, sir. Thank you. Nitin Kumar, good night, Nana. Jannapala Bhupesh, good night, Bhupesh. Pradeep, you're welcome. Abhinay Abhi, good night. Lalita Madhuri, good night. Rathod Pratap Singh, thank you for your support. So definitely I will support my students always. It is usual for me to do. And Nitin Reddy, thank you, sir. Veda Prakash Chiluri, sweet dreams, sir. So same to you, all same to you, but please do well in the exam. Otherwise, no meaning for all this. Okay. Aritra, good night. Rajkumar, good night. Pradeep, thank you for cooperation. So my cooperation for my students will all be there always. Haritra, that was a great session. Thank you, Haritra. Okay, bye. Take care and do give your best in the exam. Try to give your best in the exam, and I hope you will do excellent in the upcoming chemistry exam, students. So thanks for your valuable time and value my time also. So thanks for watching, students. Bye. Thank you. Thanks for your cooperation. Bye. And 11 members are watching, but they're not giving the reply at all. 12 members, in fact. Vamshi, band structure of solids. Band structure of solids. Already I've explained. The band structure of solids is most relevant to your lower classes. That the energy gap between the valence band and the conductance band. Just you go through it, you will get it. Okay, it is there in your physics. Okay, bye. Thank you. Have a great day and have a great Sunday and wonderful Monday. Wonderful Monday, because on Monday the chemistry exam is there, and I want to see all your faces enlightening, right? Enlightenment of your faces. I hope I can, but it depends upon your performance in the examination, right? Bye. Tomato Vamshi, bye. Bhupesh, bye. Nana. Abhinay, Abhi, bye. Thank you. You are welcome. Bye. Take care.